So this session is called Embracing Change, Collaborations, Partnerships, and the Next Generation of Innovators in Texas. This session focuses on the pursuit of academic excellence in innovative ways. We've heard a number of speakers today speak to teacher shortage, lack of teacher preparation, the concern about changing demographics, and the resulting impacts on our schools and systems. The three speakers in this session today bring you three different perspectives on improving teaching and learning in math and science. At the end of a very long day of somewhat alarming state of affairs that we've discovered today in the K-12 scene, I'm trying to hold on to the thought that this crisis is an exciting opportunity for true change. When you listen to the speakers today, you will see that some of them have grappled with that challenge, and come out quite okay. In this session, we present two innovations that can scale, and in between those two presentations, we've included the realities faced by an urban university that receives a large number of students that are primarily products of Houston schools. In this conference, that is to serve as a conversation to kick off the writing of the Texas response to the RAGS report, these are important voices that need to be included. We present three panelists as instances of many more that will hopefully be included in this report. And also, we've saved all of the foreign accents for you towards the end of the day. Although I will tell you I'm a Houstonian. I came here in '89. First, we will start with Dr. Alex Ketchtrain. Educational technology is often ignored as a potential solution for even a small fraction of our educational woes. In the days when Googling is a verb and MapQuest is what gets us from one place to another, and technology is in every part of our daily lives, it is startling still that the technological innovations do not penetrate the educational arena. Alex will ask us to consider technology as a tool to re-envision mathematics pedagogy and mathematical reasoning. Using both a personal and an educated international perspective, he will present an innovation using artificial intelligence and simulations as a setting in which to explore mathematics in our schools. We hope that the report from Texas will showcase many other examples such as this.
Well, thanks a lot, Siva. So how do I navigate this, I guess? Okay. Yeah. Well, good afternoon, and appreciate an opportunity to present some information about the innovative project that we've been implementing here in Houston, Texas for the last 7 years. I guess the slide is up. We are concerned with math education, and actually everything that Reasoning Mind does as of today is developing innovative curricular programs that are delivered to students and teachers using the web. Web is just a tool, it's just a means that we're using for delivery, but the core and the key word here is a curriculum program. And to speak about Reasoning Mind, I need to put it in a right perspective, talking about the curriculum program and the issues that we're facing in this country and in the state of Texas associated with curriculum. Rising Above the Gathering Storm report is very clearly summarizes the experiences that have been also outlined and presented in many other reports and research studies done over the last 15 years in this country. One of the major challenges that we are facing here is to make sure that the K-12 curriculum materials are modeled on world-class standards. And having an extreme diversity of school systems across the country, 15,000 school systems, it is an extremely difficult task to achieve. Curriculum materials are difficult in itself to develop, but making sure that they are world standard makes it even more difficult. One of the key words when we're talking about math curriculum that really can be used effectively in a classroom is a coherent math curriculum. A lot of research has been done to identify and clearly define what is a coherent math curriculum. One of the most prestigious and well-regarded studies, and one of the most respected studies, is the so-called TEAM study, which was done over many, many years, and that includes international context as well as the studies done in the United States. According to this study, third international math and science study, a coherent curriculum is the curriculum that leads students through a sequence of topics and performances over the grades that reflects the logical and sequential nature of knowledge in mathematics. It seems to be a very, very simple concept, but in reality it turns out that it's not usually the way how things are done in many, many American schools. American curriculum, on average, is a curriculum that presents a haphazard assortment of different topics that are taught either in isolation or in a very, very strange sequence. Well, let me give you a couple of examples. It is a very common practice to teach decimals before common fractions in 5th or 6th grade. And it is very difficult for students to make sense of decimals if they're not presented as a special case of common fractions. I've heard even of so extreme ways of teaching mathematical operations over whole numbers, decimals, and fractions as the following one. When first a teacher teaches whole numbers, decimals, and fractions and addition over all of those different forms of numbers. After that, a teacher moves to subtraction, after that to multiplication of all of those numbers, and after that to division. You can imagine that if curriculum is presented in such a way, it is almost impossible or very, very difficult for students to develop a conceptual understanding of actually what all this means. Besides that, well, in a little more broader meaning of the word curriculum, what is usually understood in other countries that demonstrated significantly higher achievement than we here in the United States. What is meant under curriculum is not just the sequence of topics, is not just only what we teach and in which sequence we teach certain math topics, but it also includes how we teach it, or pedagogies, or specific methods that have been crafted over many, many years and generations by many, many educators and tried with many, many students, and in a sense, finally resulted in a system which is in a sense an experimental system that proved its effectiveness with many, many students. And the lack of such systems and their implementations in our country, in a lot of schools, unfortunately results in relatively poor performance in comparison to other standards. Well, you've seen different variations of this slide, I think, earlier today, well, on the drop and the slope, whatever you call it. But the fact of the matter is that we are doing reasonably well in terms of student achievement measured by whatever kind of test we decide to use. That might be National Assessment of Educational Progress, that might be Texas standardized test, that can be Stanford 10 test or other tests. In essence, if you take a look at almost any of those tests, you'll see that in elementary grades we are doing pretty well in mathematics. But beginning 5th, 6th, or 7th grade, usually the performance begins to drop. And what has not been discussed in depth today is the reasons for those drops. And I'm not in a position right now to, list those reasons and argue that here's an exhaustive list. But one of the things that has been definitely established by all research studies, including the Rising Above the Gathering Storm report, is that the reason, one of the major reasons for the drop in the middle school for student performance is the fact that we are not properly preparing them in early grades for success in middle school. And this is exactly the issue of curriculum alignment. This is exactly the issue of what needs to be taught at elementary grades and how this has to be taught to ensure that students are successful in future grades. And that's what Reasoning Mind tried to achieve. We tried to take a proven, internationally proven curriculum or the system of pedagogy together with this curriculum, and using internet as a method, as a delivery mechanism, see whether we can deliver it to many, many students in this country. So this slide illustrates in essence how Reasoning Mind system works. We refer to it as a web-based educational community, at the center of which is an artificial intelligence-based tool or automated tutor, which has a face of an animated character to the students. But in a sense, behind the scenes, it is a very, very complex application that connects with students over the internet gives them assignments on the curriculum assignments that were given by the teacher, remembers everything that the students do in the system, continuously analyzes student responses, and uses the analysis of those responses to decide what should be the next best assignment given to a student. So in a sense, it is individualized instructional tool provided by a system that models very, very efficient and proven pedagogies. So what the Genie does is, by giving assignments, analyzing them, is seeing whether the student, for example, is ready for more challenging problems or more challenging material. And if the student is ready, then the Genie will advance the student to those materials. If a student, for some reason, demonstrates that he or she cannot comprehend a concept or learn an objective, then the Genie will ask itself a question: why the student is not learning? Maybe certain knowledge of prerequisites is missing, and then the system will go and automatically give diagnostic tests to a student, analyze the results of those tests, and if those tests indicate that the student needs to learn one of the prerequisites, we'll go back, reteach this prerequisite, and after that come back and continue with the instruction of the objective which it was teaching to begin with. In this scenario, certainly the role of a teacher changes drastically. Now teachers are freed from delivering the same instruction to all students simultaneously. And we know how inefficient this method is, because teachers in that setup are usually forced to teach to the mean. Well, they cannot simultaneously address the needs of advanced students, of the middle of a class, and also the students that are falling behind, that have difficulty understanding the curriculum. In the Reasoning Mind classroom, that function is delegated to a computer. But the role of a teacher is by no means diminished. On the contrary, it is significantly elevated, because now the teachers are freed to do what they do best, teach, specifically addressing individual needs of every student when those students need help in understanding the material. So in a typical Reasoning Mind classroom, you'll see 30 students sitting behind their computers, 1-to-1 student-to-computer ratio, moving on their own learning trajectory, with the teacher circulating the classroom, seeing which students need help and providing this help on a timely basis. Besides that, teachers have access through their control panel to progress reports, showing the student progress and showing exactly where each student is and how well the student is mastering the curriculum. And those tools allow teachers to interfere at the time when the student really needs help and provide this help very, very timely and very, very efficiently. And one other very important component of our system are online tutors. Because if you'll appreciate the fact that one teacher cannot possibly simultaneously address the needs, individual needs, of 30 students in a class, well, you understand why we decided that it is extremely important to have the component of online tutors, which work as virtual TAs to the teacher. So what online tutors are doing, they stand by, monitoring students' progress, and when the system flags certain students that are in need of help, and teacher approves the intervention, that those online tutors take students in their virtual classrooms and help them overcome the difficulty with understanding the concept, after which students return back to automated instruction. So in a sense, the effectiveness of the system is due to the very, very seamless and efficient integration of automated teaching with the very, very efficient and proven curriculum, individualized instruction that teachers and online tutors are providing to a student, and the ability of students to move at their pace and at their level. In summary, Reasoning Mind is not a test preparation program, and by no means it is a preparation program for tax. At the same time, students that go through our program perform on tax or at above the level of students that do not go through our program. But the main focus of the program is to make sure that students are prepared for success in future grades. They are taught concepts and objectives at earlier grades that are extremely important to teach at that age level to ensure that students will be successful. And primarily, we're talking here about early in algebraic reasoning and advanced arithmetic skills that unfortunately traditionally has not been emphasized strongly enough in our curriculum. Besides delivering these innovative tools to our classrooms, what Reasoning Mind does is paying a very, very careful attention to ensuring that what we do is clearly measured and evaluated. That's why almost every implementation of Reasoning Mind program in a classroom is accompanied by a randomized controlled trial and a rigorous research design, with the results that are evaluated independently. I'll just show a couple of recent results. In 2006 pilot project, I'll show here just a couple of schools where we used pre-test, TAX 2005 student performance as a pre-test, and you could see that the year before the intervention with the Reasoning Mind, students in experimental and control groups were doing pretty similarly. However, a year later, after going through the program, students that went through the Reasoning Mind program performed significantly better on TAX assessment than students that did not go through our program. One of the other very, very important components of our methodology is to test students also with very, very rigorous tests that measure how students do on those advanced concepts that they need to know to be successful in future grades. And for that purposes, we use the assessments that we create ourselves, and those assessments are evaluated by independent evaluators, by educators that check their content validity and report back to us whether those instruments measure exactly those skills that we want to test on students' knowledge. And last year, for the first time, Reasoning Mind program on an experimental basis was implemented as a co-curriculum program at three Greater Houston area schools. One is a Cornelius Elementary School at HISD, Angleton Middle School at Angleton, and Wilson Intermediate School at Alden ISD. At all three schools, the results of testing clearly demonstrated that the students that went through the program learned significantly at a higher level, learned those advanced skills that they need for success in future grades. So the differences between the experimental and control groups were somewhere in the range between 16 and 19%. There are certainly many, many challenges that our program faces when being implemented at schools. First of all, school needs to have very, very forward-thinking leadership to implement our program, because it is scary. You do something very, very different from a traditional instruction, and it requires a lot of courage and a lot of risk-taking really to try a Reasoning Mind program. We also need to have very, very serious and very, very solid support of leadership at a school level to make sure that the program will be implemented correctly and that we'll get help from administration overcoming those difficulties that always come along the way. Preparing teachers to use the RM curriculum is another challenge. It is a very different way of instruction, and curriculum is also very different. That's why providing necessary teacher preparation and support during the entire implementation period is extremely important. Also helping schools set up and maintain the needed technology. In this case, since we're implementing the program using technology, it is an absolutely important thing that the technology will be working at schools. In terms of implementation, we always create partnerships with schools. We are not a vendor. We are a non-for-profit organization that works very, very closely with schools, jointly implementing those programs. We teach students, we prepare students, teachers by giving them very, very rigorous qualification courses, full immersion one-week courses, and which are followed by qualification exams. We also introduced recently a teacher certification program where teachers online, concurrently with working with students in their classrooms, make sure that they learn and understand the curriculum materials and are fully prepared for advancement to future grades. And finally, we also introduced an incentive program, which is an extremely important component of what we are doing due to help and support from ExxonMobil Foundation. We reward teachers for excellent performance in our classrooms with certification awards and performance bonuses. We're currently at 15 schools with about 1,200 students. We will be expanding to 2,000 students shortly. And to summarize, I wanted to make a final note saying that what Reasoning Mind delivers currently in the classroom is really a pretty interesting concept which has been proven to work. And what is really especially interesting about this concept that it can be implemented immediately, it is inexpensive, it is scalable, and it is uniform. The curriculum that is delivered by Reasoning Mind can be delivered to all students at all schools and will be delivered at the same quality. Thank you very much. I'm a little bit exhausted my time. If we'll have time, maybe after the end of the session, and those who will be interested in a little live demo, I'll be happy to do that. Thank you.
Thank you, Alex. We hope we'll be able to include a lot of those instances in the report. Dr. Jeff Morgan is the chair of the mathematics department at the University of Houston. His view is important as he encounters the vast majority of students who graduate from Houston schools. The university has to prepare them to encounter college-level math courses. The economic impacts of this are not easy to ignore. We're spending twice, once to educate them in our schools and then to remediate at every level. These expenditures are non-trivial. As we get ready to prepare a policy report, his views and the implications therein are important to consider. Dr. Morgan will discuss various ways in which he at U of H addresses the problem and how that represents the voices of others like him.
I want to thank Siva for having the courage to invite me here today. There's always a risk having me speak, and I think that's why they put me in the last session. I'm going to give you a little history. I actually have a long-standing relationship with the University of Houston. I went there as an undergraduate. I got a Bachelor of Science in Mathematics, got a Master's of Science there, got my PhD there. Left and went to Texas A&M University, where I was a professor for 16 years, and then came back to the University of Houston. And I came back because I love the University of Houston, and I love this city. So, and also because the problems that the University of Houston faces are a lot different than the problems that Texas A&M University faces or the University of Texas faces. Those are excellent, excellent universities. But I wanted to be somewhere where we actually deal with the masses and where we have a university whose population looks like the population of the rest of the world. So let me give you some information about some observations that I've made over the last many years at the University of Houston. I'll start out with a little bit of data, which might be a little bit different from what you've seen here today. So just to give you an idea about our freshman enrollment in mathematics classes, I've got some data here going forward from 1996 up through 2007. And you can see a steady climb, and one immediate reaction might be, well, that's great. We've got a lot more students taking freshman-level math classes now in 2007 than we did in 96, and that's certainly true. But let's see a few more slides here. And I think one place people always want to look is at the calculus sequence, although I'm going to go back and look at some other classes. In calculus, we see an incredible climb in the Cal 1 materials, and in fact, here's the Cal 1 graph right here in dark blue. What an incredible climb that is from the fall of 96 up to the fall of 2007, nearly doubling the number of students that are in Cal 1. So you would immediately say, gosh, the students must really be coming in better prepared given the climbing numbers. But if you look at the numbers there in Cal 2, and there's almost no one on campus who takes Cal 1 who doesn't have to take Cal 2 in their major, you see those numbers are flat. There's a lot of students coming into Cal 1 who have been placed in Cal 1, who people say are ready for Cal 1, who aren't ready for Cal 1. Okay? We have to figure out a way to deal with these students. All right? We've got them now. What do we do with them? Let's go back, take a look back. This is just a messy slide here. But these are where the masses are. Let me tell you about some of these classes. Math 1300, that's a great course. Fundamentals of Mathematics, you know what that is? That's Algebra 1. It's Algebra 1, right? When you say the top 10% of any high school class gets into your university, you've got to do something with them when they get there. Texas A&M and the University of Texas don't have this problem in the same magnitude we have because there are a lot of inner city kids who cannot afford to go live in College Station. They can't afford to go live in Austin. They're here. We get them at the University of Houston, and now what are we going to do with them? Well, if they're not ready to go on into an upper-level math class, we've got to remediate. Math 1300. Look down here. These are fall numbers. Pretty steady across the board, hovering between 500 and 600 students. That's just fall numbers. And for the whole year, we'll see between 1,000, 1,300, 1,400 for the whole year by the time you put in the spring and the summer. That's significant. Math 1310, if you don't know what college algebra is, that's high school algebra 2. In fact, it's only a subset of high school algebra 2. Look at the numbers here. Hovering between a little over 2,000, and it looks like, oh gosh, you got way up there, but now things must have gotten better. They introduced 2 new classes, 1311 and 1312, that students can take instead of college algebra. And you see them down here with their numbers hovering up a little bit. That fills in the gap and pushes us back up here. Those are students that are really in college algebra. These are students that we have to deal with. Over 5,000 students take college algebra at the University of Houston every year. And then we have some other courses that are listed here on this page. But these are the kind of things that we have to deal with. And I want to tell you a little bit of the story about what we faced in these courses. So our concerns, of course, in these classes is, have to do with prerequisite knowledge and then, of course, student performance. Right? The same as the concerns, I guess, for high school teachers. We've got really high school mathematics courses. We've got these students here. What are we going to do with them? Right? We can't just point a finger. We've got to try to solve the problem. You've got to play the hand that you're dealt. All right? This is the hand we're dealt. We're going to play it. The same way as teachers every year. I feel bad for public school teachers. My gosh, he's showing this data that we've all seen about tax performance. It's no surprise to me that from year to year you see this thing go down. If you've only got 70% of the students that were successful in the tax in a particular grade, they go forward to the next grade, guess what? They all get passed. There are very few kids that get held back. And now the teachers have got this audience, and what are they going to do with it? Well, a certain percentage cannot possibly pass. It's going to be really, really rough. Teachers have to figure out how to make this work. They're under a lot of pressure. It's the hardest job on the planet. They've got to be able to wear so many different hats in the classroom, and they get paid horribly. People ask me what I think they should do about improving teacher quality here. Spend some money. You know what? If you pay teachers a strong salary, you'll get good teachers. There's no doubt about it. Principals the same way. People are talking about, going to have a program at Rice, an MBA program for principals. You take someone with an MBA in industry, go over to Reliant Energy. They're pulling 140, 150K with an MBA over there. What are principals making? They're not getting that, but yet a lot of principals have a few hundred people working for them, plus all these students under their supervision, big budgets. You take someone in an industry that's got that much responsibility, they get paid. How come in public schools they don't get paid? Prerequisite knowledge and student performance. Let's talk about that a little bit. So some actions that we took, because, I came on the scene at the University of Houston after being gone for a long time in 2002. And in 2003, they made the mistake of making me department chair. And when you become department chair, you can really do whatever you want. I know a chair is supposed to be different from a head, but you can be a little bit of a bully and make things happen. And it was just a disaster. Absolutely was a disaster, because an awful lot of the low-level classes were being taught by adjuncts and by graduate students. I'm sorry. That is not a way to teach mathematics. I don't care if people say it's cost-effective or not. That's not a way to teach mathematics. So the first thing we did is we got rid of all the adjuncts. And we took all the graduate students out of the teaching of fundamentals of math, college algebra, finite math, business calculus, pre-calculus. And we also got all the tenure-track faculty members out of there. Someone said earlier that just because you know a whole lot of mathematics or know a whole lot of science, you can't necessarily teach. Hey, big surprise. Universities are filled with professors that can't teach. Right? Everybody knows this. This is no secret. There are people who can teach and there are people who can't teach. Just because you know a dictionary full of jokes, you can't be a comedian. You've got to be able to deliver. And you can't teach unless you are passionate and caring and have knowledge and can switch hats at the drop of a dime. You walk in a classroom, you decide you're going to take a path one day. If it's not working out, you've got to be able to make the change on the second, take a different direction, find a way to reach these kids. What are you going to do? Just follow the path that you've chosen to take. If you do that, you're doomed to failure. Then we got all those people out of the classroom. They didn't care about our students. They were coming around for a couple thousand a semester to teach a class. And you know what? You get what you pay for. We got lousy instruction. And graduate students, you shouldn't stick them in the classroom either unless you know that they can do a good job. Not just because they're going to get a degree from you. Our students aren't guinea pigs for these people. You want to make sure they can do a good job. So we got them out, and we hired full-time teaching faculty. These were people that had a passion to teach. Anyone who sent me an application that said, I'm really interested in doing research associated with blah, 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 and that went in the trash can. I wanted people who said, I love to teach. I've got a passion for students. And then you know what? I didn't make them grade anything. They don't grade anything. They don't record grades. They don't average grades. They don't do any of the grunt work. They do what they do best. They teach. Okay? That's their full focus. they teach. Okay? Good teachers should teach. And that's what these people do. They shouldn't be taking home stacks of stuff every day to try to get through all the grading every evening so they can be so exhausted the next day that they're just dreading going back into the classroom where they have to get more assignments, get another pile of stuff that they have to grade. So we got rid of that. We went to mandatory attendance. Everybody told me, oh, these students are adults. They're adults. We're not going to make them to the class. That's bull. You know? You're competing for your students' time. Everything in life is competing for their time. And if you don't go after that time, guess what? They won't spend time on what you want them to spend time on. So we make them come to class. They get a daily grade every day when they come to class. They walk in the classroom with what I call the low-tech clicker. They have a special Scantron form they carry to class with them. Periodically during the lecture, the instructor just throws a question up on the screen. This is number 3 on today's popper. It's multiple choice. You got 30 seconds. At the end of the hour, they drop it in the box on the way out the door. They get an attendance grade for that and a daily grade based upon their responses. And we've got lots of data to work with. You say, why don't you use the clickers? Okay, come teach at the University of Houston with the average students and let 25% of them lose them all the time, and you'll know why we don't use clickers. Written homework. You say, written homework? That's awfully low tech. Our students turn in written homework every single day. Okay? Every day. The teacher doesn't grade it. Okay? We have assembly line grading that's handled. We've got a group of people, they bring in a stack, they say, we're grading Math 1310 this morning. The first person grades problem number 1, passes it on. The next one does number 2, and they just keep going like that. Uniformity, you take a stack like this and go to this in no time at all. They've got weekly online quizzes. They can take as many times as they want. We keep the highest grades. You'd think that every student would make 100 on that, right? Wrong. The only students that make hundreds are the best students because they get in there and they take it early and over and over and over again. And the students that really need the bump in their grade, the CDF students, you know what they do? They wait till 1 hour before it's due. And that's the first time they log in and they open it up and they do it. And they can't understand why they're struggling. We have a lot of increased tutoring availability. We have in the Center for Academic Support and Assessment we run, it's half testing, half tutoring. In the tutoring side, there are 120 seats. They're filled all day long with students getting tutoring help, face-to-face tutoring help. We employ between 60 and 80 tutors, proctors, and graders over there in that center. We have common exams and common grading. No cowboys. All right? Everybody who's teaching college algebra, I don't care who they are, they got the same syllabus except their names in there. They get the same homework assignments, same online quizzes, common exams. They're not allowed to curve their grades. Absolutely, positively not. You buy a shirt at Sears at 10 o'clock in the morning. Nobody in this room shops at Sears. Okay, you go to Joseph A. Bank. You buy a shirt at 10 o'clock in the morning. You buy that same shirt at 3 o'clock in the afternoon. You expect it to cost the same and be the same quality. Why shouldn't it be the same with classes? Right? And then we've got some real data where we can compare instructors. And guess what? There are some people who are better teachers than others. Consistently, some of these people outperform everybody else. And it's not just by a marginal amount. It's significant. And I think we've improved instruction. Course coordinators, we've encouraged people in these classes to let the students know on a regular basis that they care about them. And we encourage them to create great materials, and they all share their materials. All the teachers from all these sections share all their materials, and the students can access any of it, which I think is wonderful. Now, let me give you some performance data. I've just brought the fall 06 numbers. This is after implementing this change. This is in college algebra. Now, I've gone to many universities around the country, talked to people about college algebra, and I've been some places where they had me come in and they said, gosh, you know, our success rate in college algebra is about 30-something%. It's a rough class. It's rough. The students that are in there, they struggled in math when they were in high school. Now they're at the university and they're still struggling. I'm showing you some numbers here. Now be careful when you read this. Cumulative percentage is different than percentage. This says 100% of the students got W's, F's, D's, or above. That's what that 100 means. 88% got F's or above. That doesn't mean 88% of the students got F's, right? So you see we've got pretty good success. 32% of the students that came in got A's, 20% B, 15 C, 10 D, 12 D, and only 12% W's. That's significant because at the University of Houston, the average drop rate in college algebra, not in college algebra, in all courses is 30%. You're at a university where the average commute time for any student is about an hour each way. You've got a whole lot of students every day that say, I'm not showing, right? And you miss enough classes after a while, you just become a casualty, right? You just got to drop out. That's amazing. Only 12% drop rate in that class, I think. Going back and looking at data from previous years, it used to be when they had adjuncts and graduate students teaching the class, they were testing more or less the same as we are now. Only before, if the average was a 45, they said, okay, we'll call that a C and we'll curve it up. Because they wanted to keep getting employed every semester, and the math department wasn't going to employ them if they just failed all their students. Right? Just call that a C and just go on with your day. These are real grades. We don't curve anything. Right? 90 to 100 is an A, 80 to 89 is a B. That's it. Where it lands, it lands. So I said we've got improved student performance with increased standards. And, I'm happy for that. I think the bottom line is there's nothing special here. We didn't change the curriculum. We made the students accountable. They have to come to class. They've got to do work every day. They have to turn in written homework every day. They've got to do the online quizzes every week. They're responsible for getting work done. We're bargaining for their time, and if we don't do that, we won't get it. Pre-calculus is a tougher subject. Again, you see we've got good retention here with only 70% drops, but only 57% of the students are getting C or above. It's a rough class. Big drop-off from college algebra, going back up 66 C and above 57. And calculus is another story entirely. And it's been hard for us to make change in calculus, although we've finally got it going. And the reason it's hard to make change in calculus is because that's where we've got our tenure-track faculty members teaching. And I don't know if you've ever gone to a tenure-track faculty member and said, from now on, when you teach this class, this is what you're going to do. You know what they're going to tell you? Not if I don't want to. Right? So somehow we managed to get everybody to agree to common exams. There was actually a lot of arm twisting there. Once you get people to agree to common exams, other things start falling in line because now there's peer pressure, because you start publishing the data for how students do in the different classes. And it used to be that very few people required weekly written homework. They thought that was silly, which I couldn't understand. Because if you don't make the students do it or do something, they won't do anything. They'll wait until it's time for the test and try to cram it all on to the last minute, and they won't learn the material. But then these numbers started coming out on performance of students in different professors' classes on these common exams, and all of a sudden the professor's like, oh my gosh, my students are doing horrible compared to these other people, and I can't curve my grades. What am I going to do now? I guess go talk to this other professor and find out what they're doing. Oh, you're making your students turn in homework? Okay, yeah, I'll do that too. So now they're all doing online quizzes since 2005. They've all got course materials online, and we've got lots of common materials online, including textbooks. 75% of them are now requiring weekly written homework, and I predict by fall of 2008 it'll be 100%. Daily class grades, only 40%. Mandatory attendance, only 40%. And I'm thinking by fall of 2008 that'll be 100% also. And peer pressure, this thing at the bottom, really can work wonders. When you start sharing data on student performance in different teachers' classes, people that aren't performing well, they want to make a change. Right? No one likes to be publicly embarrassed. And someone says, oh, you shouldn't do that. Oh, bull. Okay? Let's get the numbers better. We're here to help the students, not to make some professor feel good about what they're doing in the classroom. Okay? Performance in Cal 1. It's almost shameful. 51% of the students that come into Cal 1 are getting C's or better. Going back to that earlier slide where we see this huge performance in terms of the number of students enrolling in Cal 1, and then we see it flat in Cal 2. There's why it's flat. You can't go on to Cal 2 if you don't get at least a C in Cal 1. This is a death sentence. You go into Cal 2 with a D, you're failing for sure. Right? We have managed to keep the drops low. I know Stephen wants me to shut up. I'll pass all this stuff. Just want to make a couple comments. We have some outreach activities going on. I'd like to show you some other numbers, but I just talked way too much. High school math contest, if you're in this area, get your students to come on out. They have a great time. We give away all kinds of free stuff. The teachers all get lots of free stuff, which I think is important. My gosh, teachers take their Saturday to bring kids out to a high school contest. They should get something for it. Teachers work so hard. And we'll give away hundreds of free T-shirts to students, lots of prizes. It's a great contest, and it's local, right? Houston Area Calculus Teachers Association, we've been in partnership with them now for 7 years. It's directed from the University of Houston. We run 5 AP Calculus workshops a year, absolutely free to teachers. They can come out. Next one's next Saturday. Dixie Rocks is going to be there, and she'll do a great job. Eat Math, Algebra 1 teacher workshops, we run 4 or 5 of those a year. They're also free. sponsored by the university. Online AP calculus testing, absolutely free. Last spring we had 1,000 students take AP exams online. Doesn't cost anything. Students can take these exams and get practice. I think it's a wonderful program. We're going to start doing the same thing in AP Stat in the spring of 2008. We've got projects going on over at Yates and Sterling, generous funding from the GE Foundation, helped get that started, and then the University of Houston jumped in on the Yates program. Very thankful to them. And then this great program at the University of Texas, You Teach, which we're starting to replicate at the University of Houston. It's called Teach Houston. It's so important to do these kind of things. We have to pay a lot more attention to how we're training teachers, and we've got to find a way, as they're doing, to get people out, make it possible to get people out in 4 years. Why should people have to stick around and work harder to get a degree where they can enter into the hardest profession on the planet that pays the worst? Okay? So the programs like You Teach, these are great programs, and I'm happy to be involved in the replication at the University of Houston. And Siva, thank you again for letting me talk here today.
After a day of seeing a broad set of data, it's actually nice to zoom in and see what that means for an individual. And for the last speaker this evening, we chose Chris Barbic, a rock star in the world of education, locally and nationally. Chris is the head of Yes Prep Schools and a Teach for America core member. He's been in Newsweek more recently, but is written up in many places. Just Google him to realize this. Founded in 1998, Yes is a free open enrollment public school charter system that serves low-income minority students in grades 6 to 12. His charter mandates that students must be accepted to a 4-year college in order to receive their high school diploma. Yes is the only school in the greater Houston area to make Newsweek's list of top 100 public schools in America for 2 years in a row. Houston Press, a rather controversial rag, names Yes Prep the best school in Houston. If you have not heard of them, they're about getting every kid to college and making that happen. If you call their phone and they're not there, every staff member's voicemail at Yes repeats this message: we are doing whatever it takes. What a powerful culture, and Chris engenders that culture. But as has been said before today, Chris is at the tipping point of his innovation. He is attempting to add a significant number of schools that will add a high-yield number of underrepresented students seeking college education. He is going to speak to these issues of scalability.
Thank you to Tamis for allowing me to come. I want to start off by saying I'm an English major, so I'm sure I'm bringing down the math and science IQ by being up here and speaking, but I'm going to do my best to hang in there. I don't have a PowerPoint slide, so I'm just going to talk fast and hopefully leave some time for question and answer. I wanted to hit 3 things. One was we've been the best kept secret in Houston. As much as Siva was kind to talk about what we've done, there's a lot of people that don't know who we are. So I want to spend just 30 seconds giving folks a bit more background on who it is we're serving. Talk a little bit about the lessons we've learned. We've been at this for about 10 years now around math and science curriculum and instruction. What we think is the reason why we've gotten some pretty terrific results in the areas of math and science for our students. A lot of it's the stuff that Jeff was talking about, just doing it earlier. So I'm not going to repeat a lot of what he said, but I want to add a couple things there and then talk a little bit about our plans to scale up and why we hope to do that and what we hope to achieve by working in concert with other charter groups and along with the ISDs here in Houston. So just a brief background on us. So we basically exist because when I was teaching in HISD over in the east side of 92, I got tired of watching kids leave 6th grade and go to middle school and just do nothing, and call me and ask me to give them homework, and just one story after another of why kids weren't doing well. And when we started to dig into the numbers and look at what's happening to kids from 6th to 12th grade, what we found is there's about 15,000 6th graders in Houston ISD, and about 7,500 of those kids are going to finish high school. And then if you apply those numbers and just track national averages for the different ethnic groups of who enters and finishes a four-year college, if you're a sixth grader in Houston, because everyone likes to pick on HISD, but guess what? The numbers ain't that much better for Aldine, Alief, and Pasadena. No one talks about them as much. It's about 7%. If you're a African American or Hispanic sixth grader in this city, you have about a 7% chance of finishing a four-year school. And when you take that and you compare it to what the demographic trends are looking like over the next 10 or 15 years, Houston's going to look like a third world country, and there's some folks that argue that it does right now. And there was something I read in the executive summary of the Gathering Storm Report that really struck me, and that is, this is a silent bell that's going off. I mean, it's not all of a sudden one day an alarm's going to go off and say, hey, we've hit all these things that we're talking about that are about to happen. Guess what? This is the day that it's starting. I mean, this is a silent bell, and I would argue that the bell has been going off for about 5 or 10 years now, and there's lots of great reports that have been written, and there's lots of conferences like this, but it's going to take a lot more than that to change this thing. And so I want to talk a little bit about that in just a second. We have 5 campuses around Houston. We're serving about 2,100 students in the greater Houston area this year. We start in 6th grade. When our first school, the Southeast campus that Siva mentioned, was in Newsweek. We've graduated 7 classes. There will be about 300 alumni. About a third of them stay here in Houston. About a third stay in Texas, and about a third leave the state for four-year college university. About 90% of our kids who graduate from YES have either graduated from a four-year school or are still enrolled. So that's the big question we could ask. What's your success rate after kids leave? It's pretty high. And math and science is the most popular major of our students who are in a four-year school. A lot of our kids are in engineering programs. A lot of our kids are in teacher prep programs in both math and science. 99% are minority. About 80% are qualify for free and reduced price lunch, and about 90+% not only are still enrolled or graduate from a school, but are also first-generation college bound. And so that's kind of who we're serving. So it's a lot of what you guys, I think, were talking about this morning in terms of the student profile. And around math and science, in terms of what we've learned, and to be quite honest, it's not just in math and science curriculum, but just in general, kind of, folks like to ask, what's the secret sauce? What are you guys doing differently than other places that are allowing kids coming from those backgrounds to achieve at the levels that they're achieving at? And I think there's a few things that we're doing that are pretty easily replicated in other places. First is college prep can't start in 9th grade. College prep needs to start at a minimum in middle school, and you can make a really strong argument that it starts way before that. But there's a lot of pressure put on high schools, especially 11th and 12th grade, on all these numbers of why kids aren't doing well or not even enrolled in school. And the fact is, they're not showing up in 9th grade knocking it out of the park. They're showing up in 9th grade 4 or 5 grade levels behind. And now you've got teachers and administrators who are expected to make up 8, sometimes 9 years worth of curriculum instruction in 4 years on when you take out restroom breaks and passing periods and lunch and electives on a 4-hour school day. Well, that's not possible. You can't do that. So college prep has to start in 6th grade. We firmly believe that. In math and science, that means you got to have good people in front of kids who know what they're doing. And you can't cover decimals, ratios, and percents for 6th, 7th, and 8th grade, which is what happens in a lot of middle schools. Teachers are doing, basically what they can do, which is cover decimals, ratios, and percents 3 years in a row. And, what we would argue is, Algebra 1, that needs to get knocked out before kids start in 9th grade, and that should be a bare minimum. So what do we mean by great people? I completely agree with what Jeff said in terms of, folks need to be smart. They need to be passionate. They need to love what they're teaching. They need to know it really well. And the third thing that we look for is, can you connect that with kids? Because we have a lot of folks who come and interview with us who are really smart. And they get so fired up about stoichiometry, it makes my head spin. But you know what? When you put them in front of 38th graders, their ability to connect that passion and intelligence with an 8th grade kid coming from the east side of Houston, if you can't do that, then all that passion and intensity and love for your content area gets completely lost. So that third thing, and it has to be all three. It can't be one or two. It has to be all three of those things. So we really look for those great people that we can put in front of kids and make sure that they're ready to achieve at high levels by the time they graduate from YES. Our 6th and 7th grade curriculum Kids are doing about 2 hours of math a day. There's a lot of remediation. Most kids that come to us in 6th grade, if you look at their Stanford scores, they're about 2 grade levels behind. So our job is by 8th grade, they're taking Algebra 1. So we're basically doing 4 years of math in some cases, in a lot of cases, in 2. Well, again, if you want to do that, you got to create more time. So our kids are in school longer. They're going to school to about 4:30 or 5 each day. We have classes on Saturday once a month, and we go 3 weeks in the summertime. And it's pretty simple. If you want to create the extra time that you need for kids to learn, then you got to, again, you can't do it in 4 hours of instruction a day. Around instruction and assessment. So we've gone all across the spectrum. When we started, we were a service learning school, so it was all project-based. And what we found was kids could tell you all these intricate things about the transportation project they did, but they didn't know who Thomas Jefferson was. So that was a problem. So projects were fun, and it got kids to be there every day, and they could, they got super engaged, but there were huge gaps in what they were learning. Well, then I picked up an E.D. Hirsch book and read The Schools We Need and Why We Don't Have Them. And then we went from project-based learning to core knowledge in like 9 months, and everyone on staff freaked out. And it was, it was a scope and sequence of this is what kids are going to learn, this is how we're going to do it, and it was a very scripted out approach. And so you can imagine folks that were doing, project-based learning to that. We had a small well, actually it wasn't even small. We had a large mutiny on our hands in terms of where the teachers were coming from for a while. And so what we did is we kind of met what I would say in the middle. And what we do is we define the what. So we have a scope and we have a sequence that we ask teachers to follow in every single content area from 6th all the way up till 12th. And we haven't rolled all of them out exactly, but we have in the math and science areas up through 9th grade, actually up through 10th grade. And so when we bring somebody in, because most of our teachers, just to give you an idea of the staff at our school, we hired 80 teachers last year. 45 of them have never taught. They have no teaching background at all. So these people want some sort of guide. They want a roadmap of where they need to be and what they need to be teaching. And so we give that to them. What we tell them is, how you do it is up to you. We're hiring you because we think you're smart, we think you know your stuff well, and you demonstrate that you can connect with kids. And we have everybody that comes in and teaches it, yes, do a sample lesson for 45 minutes, because a lot of folks can walk into an office and tell you all the things you want to hear. Again, you put them in front of 38th graders and it's a different person. So we watch people do a demonstration lesson for 45 minutes before we hire them. And then we tell them, here's the what and here's where you need to be. How you get there is up to you. You're going to have a common assessment that everyone's going to take, 6th grade math, for example, at every campus that we run at the end of the semester, and here's what's going to be on that exam. Or not, here's the sequence of things that are going to be on that exam. And then we give the test. And like Jeff was saying, the data don't lie. Right? So when we sit the 6th grade teachers down and we talk about, what people did, it's not punitive. It's not to embarrass anyone or make anyone feel bad, because our teachers are working hard. They're there because they're on a mission. I mean, no one's there slacking, all right? But what it does do is it creates collaboration. It actually forces collaboration, because we'll see by objective where kids are scoring, and if someone's spiking on an objective, then we want to send the SWAT team into that person's classroom and find out what the heck they're doing and bring that around to everybody else in the system. And we have teachers who want that. They want that knowledge. So you have this great synergy of folks who are hungry for the information and a system that's able to capture that information and then spread it around and create ways for teachers to collaborate. And when you do that, you just watch the achievements start to go through the roof. So common assessments and a scope and sequence is, we believe, really important. I think the last thing I want to say before I get into kind of the scaling is, I've never heard a teacher who starts the beginning of the year, if you talk to him, say, we set low expectations for our kids. When we come in and we don't expect anything from our kids, and we are all about low expectations at the school. If you talk to any teacher or any administrator, they're going to tell you they have high expectations. The problem is the expectations are here, and then the kids come in somewhere here, and then everyone kind of meets somewhere in the middle, and you're left with mediocrity. Right? And I think so high expectations alone isn't enough. And, I was talking to an HISD administrator about a month or so ago who worked at one of the better high schools in the city, and they gave a survey to their teachers at the end of the year last year, and I forget exactly what the question was, but it was around, do you just fundamentally believe that your kids can learn? and 66% of the teachers didn't. And this was at a pretty good high school. So when that's the people when that's your raw material that you're working with, that's a problem. So, you've got to have people who, in their heart of hearts, fundamentally believe that if you give kids from any background the same access to opportunities and resources that kids in great private schools have and great suburban public schools, you got to have people that fundamentally believe that if you do that, the kids are going to achieve. And that sounds like a really simple thing, but that's not happening in a lot of our middle and high schools in this city. And I would argue that it's not happening in a lot of middle and high schools in lots of places. So you got to have that. But that alone isn't enough. Just getting folks who have high expectations and believe, you've got to have an infrastructure and a support system that when your expectations are here and the kids come in here, that you're reaching down and meeting them where they are and getting them back up. And that takes a lot of hard work. And I could go for 2 hours on what it is at Yes, and that's not important because I don't think that we've got it all figured out. But what is important is that a school and a team and the leadership and the teachers, A, have recognized that, and B, have figured out what that is. Does that mean you make the school day longer? Fine. Does that mean kids come in on Saturday? Great. Does that mean you have a very distinct profile of the kind of people you want work? Then whatever it is, something needs to be there because otherwise you're going to get a lot of this, which is what we have in a lot of schools right now, which is a lot of mediocrity. And you saw the numbers that Jeff put up. That we see where that gets us, and it gets us into a pretty scary place. So we've had some decent success at one of our schools. Siva mentioned we were in Newsweek, and when we set out to do this, the hypothesis was what I just mentioned. If you give kids access to the same opportunities and resources that they get at a great school, they'll do just as well. And we believe that the Newsweek rankings support that. We were 38th in the city, ahead of any other public high school in Houston. Memorial, Bel Air, you name it, we were there. And these were kids who 80% of them were low income. So we feel like the hypothesis has been proven at least at one school. And now what we want to do is we want to try and prove that we can create a system of these schools. So we have 5 campuses right now. We have, funders in the room, the Houston Endowment in particular, Texas High School Project, who have helped us get to the point of scale that we are right now. And our goal is to reach about 10,000 students in Houston. And the reason that we want to do that is there's 3. One, we have a huge waiting list of kids at some of our campuses who want to come to Yes, who we can't serve right now. And we sat down and spent a lot of time thinking, okay, do we, make the school bigger? Or do we open up more schools? And we decided that the size of the school and the relationships that we were able to build on a single campus were an important part of why we've been successful. So we chose to open up more schools. The second thing is that our sort of theory of change is that if you create a critical mass of college-educated citizens who live in a low-income neighborhood and who aren't there because you've torn down all the houses and built nice townhomes, but families that grew up in that community and have a connection to that community, if you create that critical mass of college-educated citizens and you instill in them a desire to come back and serve their community, that's the way you make change in a low-income neighborhood. And so YES stands for Youth Engaged in Service. And part of our mission is not just make sure kids finish college because there's a lot of financial stability and good things for families that happen from that, but it's also you need to come back to the neighborhood and make sure that you're picking up 3 or 4 other people and helping them get to the same place that you are. And so getting that critical mass with one campus at 100 graduates a year was, I'm not that patient. So we wanted to get to that critical mass a lot faster. And so that was another reason driving our growth. And then the last one, which is kind of a modified sort of theory of change, is that we think that we can have an impact on the larger school system. When we first sat down to do this, trying to reform larger systems, we actually decided that wasn't part of what we wanted to do. We just wanted to focus on community redevelopment and have things change that way. And what we recognized is that was probably a little naive, and that we were missing a huge opportunity. And so what we want to do is through a right blend of competition and cooperation with large ISDs, we think that we have a role to play. And I think, I have a friend, Mike Feinberg, who runs KIPP, and I think the analogy that he uses is the right one. And that is that I think the role that high-performing charter schools play and the ones that want to replicate it is that, we're kind of UPS and FedEx to the post office. And what I mean by that is that we're not going to deliver everybody's mail, but there was a certain point where the post office said they couldn't do overnight mail. And when UPS and FedEx got to a certain size, they figured out how to do overnight mail. I think that's the role that we can play in the school system, is through some outside pressure, some outside competition, but also working with school districts like we are at Lee High School right now. We just opened up our campus inside Lee, and sharing best practices and working with the school district, that right blend will help us have a larger ripple effect on the city, and that's what we hope to do. So I'm going to stop there and hopefully have time for some questions. Thank you.
Chris, I'll just work backward. There's a question for you. How do you create and sustain a culture of high, I don't know what that is, and quality classroom teaching? How do you get teachers and students to buy into a new way of doing business? I mean, a lot of it happens on the recruiting end. As far as students go, I mean, we're very upfront with families about what it is we're trying to do. And we start in 6th grade, and families know that in order to graduate from a YES prep campus, you have to get accepted to a 4-year college university. And, we're very upfront about that. It's a choice. It's a lottery. We have kids who are in special ed, and, we deal with all the same warts and hairs that large ISDs deal with. But I think, families have to choose to come to YES. So I think there's power in that choice. And so I think that's part of it. And teachers choose. No one gets to enroll at YES or come to YES because they live across the street from the school. That's not, no one does. So I think that's a powerful thing for our families. For our teachers, again, they're there because they believe in the mission of the school. Do we pay a little bit more than the regular ISDs? Sure. Is there a performance pay system? Yeah. But that's not why people are working at YES. They're working at YES because they want to work on a team. They want to be part of a mission. They buy into what we're doing. It's an exciting place to work. You're surrounded by great, passionate, and smart people. And that's the culture of the school. And now that we've been doing it for 10 years, that culture started to, kind of sustain itself. But I will say that finally that, we do lose teachers. And I know this was addressed earlier, but, my belief and our belief as an organization is that the days of someone teaching for 20 years are over. There's no one doing that in any profession anymore. And to expect someone to come in and teach 3rd grade math for 20 years, I think we're kidding ourselves. If we want smart, driven, ambitious people coming out of college who have some drive, those people don't want to do the same thing for 20 years, even if they're working at the same company. And some of you who are just out of college, I mean, how many of you have friends who are doing the exact same thing 5 or 6 years later with the exact same company? It doesn't happen. And so I think we need to recognize that and set up our recruitment and our professional development the way we're doing that around the idea that folks are probably going to teach for 5 or 6 years, and that's it. And especially in the neighborhoods where we're working, I mean, this is exhausting work. I mean, that's like asking a doctor to do their entire career in the ER. You can't. You need to go and refill the pitcher. And so I think, the way we do that is we have a young staff, and, we don't beat ourselves up when folks leave after 4 or 5 years. We know that that's probably going to be reality for us for as long as we're in existence, and we hope to be here for a long, long time. So, Alex, this one's for you. Is there any way for students who are at the same level to collaborate, or high-performing students to aid others? If not, can you see a way to integrate collaboration so students can students can develop these skills?
Oh, absolutely. Students do collaborate in the reasoning mind system, and there are many different ways of doing that. Well, to begin with, students work together in teams. We seat students based on their level, and the way we do it, we seat usually students that need help with those students that are more advanced. And those students that are more advanced usually help students that require certain help. In addition to that, we have a kind of function that's called kind of genie helper, a student that is so advanced that it is capable to help teacher help other kids. In addition to that, students do play games through our system with each other and compete and collaborate with each other in solving math problems. So there are many different other ways, other activities besides just the student sitting in front of the computer and working on his or her own. Yes, collaboration is a big part of reasoning mind.
Jeff, this one's for you. How does the U of H pay for all of these math services? Was there resistance from the university when you sought these changes?
Well, we recognized ahead of time that these things were going to cost money. And we started sitting and thinking about how we were going to pay for these things. And actually, when this stuff started happening, I also had another burr that was bothering me, and that was textbook prices. And at the time, our students in college algebra were getting gouged for $100 for a college algebra textbook, which I felt like was outrageous. And I went and I talked to the publishers, and I said, what in the world? This course hasn't changed forever. Why does it cost $100 to put this book in the bookstore? They said, well, by the time we send it over there and Barnes & Noble marks it up, it just costs $100. That's just the way it is. Well, it wasn't long after that a different company came to me who hadn't been getting much business there at the University of Houston and said, you know what, we can put a book over there in the bookstore for your students, and after the bookstore marks it up, it'll only be $53. Then another company came to me and said, we could put a black and white textbook over there in the bookstore, and it would only cost your students $20. And it suddenly dawned on me that universities have been having their students pay list price for books for a lot of years. It's like going on a car lot and looking at the sticker price in the window and saying, I'll pay that. Right? We select a text based upon what we think's in there, but we never bargain price with the publishers. Turns out you can. Now, in terms of how we paid for this, now let me go a little bit further. We finally decided to heck with you guys. We created our own materials for college algebra, for the fundamentals of math class, the pre-calculus course. The students pay a $20 course material fee to access all this stuff. The difference between the $20 and the $80 that they would have paid for the textbook, a portion of that went into fees to help pay for all these other programs. And then for the students that weren't in these classes, we went back to the publishers and said, you know what, you're not shipping your books to the bookstores anymore. We will give you $20 per student to lease the PDF files for your text. Play or don't play, tell us right now. If you want to play, then you send us the PDF files. You don't ship anything, you don't restock what doesn't sell, and you get $20 times the number of students. Decide you don't want to play, you get nothing. What do you want? Guess what? They were willing to pay. In finite math, business calculus, Cal 1, Cal 2, Cal 3, they all paid. They all played, and the students paid $20 for access to those materials. They can print if they want to, not print. People say, oh my gosh, they can print, they can steal it. Listen, you're kidding yourself if you don't think students can print anything that comes up on the screen on their computer. Okay? It's called a print screen. Okay? Or they can take a book that's already in print, rip the back off, put it on a form feeder, and PDF the whole darn thing. All right, so you got to forget about all this copyright stuff. That's how we pay for these programs. We brought down the course to cost materials in the course, then we ramped up some fees, and we landed somewhere in the middle, and that's how we paid for all this stuff.
That's awesome.
Chris, this one's for you. Your programs exemplify rigor. What are the negative consequences of rigor? What are the positive consequences?
That's a great question. Well, the negative consequences are that, I talked about the power of choice. Well, that means there's a power to unchoose too. There's kids who choose not to do the work. 7 years is a long time. And it's great to talk about college to a kid who's in 6th grade, but 7 years is an even longer time for a kid in 6th grade. So you got to make sure that you're creating things along the way to keep them in the saddle, and that's hard to do. It's really hard to do when a lot of your kids are coming to you behind grade level. The challenge is making sure that as many of those kids who started with you in 6th grade are finishing in 12th. We've not, I'll be the first to admit we have not figured that out completely. Our attrition goal each year is below 5% per year per campus. And last year we had 4 schools and 3 of them were able to meet that goal. But even then, even if you're at 5% over 7 years, you're losing 35% of your kids, and that's a lot. So that's something that we're still working on. The positives are that kids, see what they can. It's amazing to watch a student who comes to you, behind grade level who's been told for a really long time there's things they can't do. We had a kid, Walter Brioso, who came to us in 9th grade from El Salvador, who we went and tested at a psychology, one of these psychologists, and after the test, she sat down with him and his father and said, I don't know why you're at a college prep school. The best you're going to be able to do is to learn a trade, and to you need to transfer from the school right away. I mean, she crushed this kid, right? That kid hung in there. That kid graduated. He's majoring in engineering. And the first thing we did when we got the acceptance letter from Midwestern State was we faxed it right to that psychologist and said, just want to keep you abreast of our progress. And so that's the positive of rigor is watching a kid like that who's been told that he shouldn't be in a college prep school. And is he going to take 6 or 7 years to graduate from Midwestern State? Sure. But who cares? He's going to finish, and he's going to have an engineering degree. And so I think that's the positive of rigor is watching, and there's lots of stories like that we've been able to be, fortunate enough to be a part of over the last 10 years, and that's been cool. That's why we all get out of bed and do what we do. So.
This one, Jeff, is for you. Can the student access the online material from the home or dorm?
They can access it from anywhere where they've got an internet connection, and there's a lot of material up there available to them, including streaming material, textbook-type material, step-by-step material. All the online quizzing and stuff is available. They get immediate feedback on that, find out which questions they get right, they get wrong. Let me just say something about what Chris said a second ago here. I want to tell you, I got a D in Algebra 1. Okay? Probably would have been plenty of people who would have said, I wasn't going to make it. And when people ask me why we teach college algebra, why we teach calculus, these kind of things, we don't know a priori who's going to need this stuff. Who's going to be the next great engineer, scientist, anything else? We don't know when this person's going to wake up. I'm not saying I'm a great mathematician, but I woke up at some point, and I know lots of students over the past 25 years that I've seen in my classrooms who, during that semester, I thought, oh my gosh, I'm doing the best I can for them, but I'm thinking, I'm never saying anything. Wow, this kid's really struggling. Years later, I see them, and they've somehow managed to get it together. You don't know who it's going to be. And I've seen plenty of other kids that I would have bet my bottom dollar on that they were going to make it who never panned out. We don't know, right? We teach these students because we don't know who's going to make it, and we're counting on the ones that are going to make it to be equipped when they get there.
That's right.
Well, you might have noticed that we were missing a panel member. Michelle Pola, who's the chief of staff at Houston ISD, couldn't be here because she had to deal with a mother's health emergency. So we're actually going to end a little bit ahead of time and close. So thank you all.
Thank you, Siva. That you said you were going to shake us up, and you did. That was a terrific way to end this remarkable session we've had. But we really saved the best for the last here, and that is we've got Dr. Larry Faulkner. So many of you know him, president of Houston Endowment, past president of the University of Texas, great scholar here in Houston. We're very proud of, and he's agreed to present some closing remarks. Larry.
Well, thank you, Bill. There's been a lot of speeches today, and I've taught for a long time, so one of the things that I'm going to do is ask this audience to stand up for 30 seconds. Give yourself a little bit of a break here. While you're standing, I'll get you seated here in a minute, but while you're standing, I'd like to on behalf of this whole audience, thank Neil Lane especially, but also the TAMIST Education Committee and all the panelists and speakers who have been here today. They have put on quite a show. This is a program that has been conducted by people I know to be heroes and heroines. I have worked with a large number of people who have been on the program today, and they are terrific people. We have been treated to the point of hearing them talk about what they've been doing and their ideas for improvement in a very critical area. Let's thank everyone. Neil, the TAMIST Education Committee, all the speakers, all the panelists. And now you can sit down. Actually, I was interested in what Chris said, that people are going to teach for less time. I taught for 40 years. And it was a pleasure at the end, too. I'm not doing that now. I'm giving away money. And I want to say that I did make some comments a minute ago about heroes. There were heroes here on this last panel. The most enjoyable moment that I've had in the time I've been at Houston Endowment was being a part of handing Chris Barbic a check for $10 million at the Avalon Grill. It was fun. Yeah.
I drove immediately to Co-America Bank. I've never been treated so nicely.
Mike Feinberg was also there, and Houston Endowment was putting $10 million into the KIPP expansion as well, but he has to wait for his money. We gave Chris his all at once. And we're also supporting Alex, not at $10 million, but we are putting money into Reasoning Mind. And Jeff, I was wondering why we aren't writing checks to you. But these guys put on a great show, and this whole program, I'll say, Neil, I've been surprised at how much I've learned here. As I said, I've been around these people. I've been around these programs for quite a long time. I've been thinking about these issues, but I think the quality of discussion here has been very good, and I'd like to do the job that you asked me to do, which is really to kind of bring things together and make maybe some macro points. I'd like to make 2 quick points, and then I'll actually get to my messages. While people were talking today, there were a couple things I wanted to comment on. First of all, Dixie Ross opened the program by making a reference to John Kennedy's Man on the Moon speech. What she didn't maybe know, because as we were talking about it at lunchtime, is that John Kennedy delivered that speech in Rice Stadium right over here on September 12th, 1962. Houston was already a place that had ambitions to play a role in the space program, and the Man on the Moon speech was delivered right here on this campus, so it's sort of appropriate to cite that given what we're talking about right here today. Second, I'd like to comment on the top 10% briefly. Richard Tapia brought it up, and I think that he was in some ways complimentary about UT. But I'd like to comment on a couple of things. First of all, Richard said that no educators were involved or would have been involved in the creation of it. That's actually not true. That law was enacted under the leadership of Irma Rangel, the late Irma Rangel, who was at that time chair of the House Higher Ed Committee, in response, as Richard said, to the Hopwood decision's devastating effects on the ability of Texas universities to respond to needs to build diversity. And the top 10% law, though, was created by Chairman Rangel in close collaboration with leadership at UT. Ricardo Romo, now president at UT San Antonio, was a very engaged figure in the development of that law. The second point I want to make about the top 10% law is that when you look at what's happened in the face of that law to diversity at UT, it's a record that UT can be proud of, but I want to say that UT put tremendous effort into making that work. It wasn't just having the law enacted and just letting the law work to create those effects. Those effects were gained by building off of that law and having people from the university show up in high schools in Houston and in Dallas and in Fort Worth and San Antonio and in the Rio Grande Valley and all across this state, and to make presentations to students, groups, and talk to them about why it's important for them to take advantage of the opportunity that that law creates. And doing that year after year after year has created an understanding in families that did not exist. But I can tell you that it was work on campus, as Richard acknowledged, and work off campus to try to get students and families to understand what that law offered. So I just wanted to make those comments about the top 10% law. It is true that UT has been able to rebuild its diversity after a big hit following the Hopwood decision, but there's lots of elements in it. We've heard a lot of statistics today, and I was thinking as we were going through about a quote from Mark Twain: "Facts are stubborn things, but statistics are more pliable." We saw a lot. People were citing things to reinforce one view or another. I think that in the world of education, the directions to go are never all that obvious. It is important to keep pushing and testing your own views about what the next best steps are. Now, let me make a few comments about what I draw from today's discussion and actually from years of thinking about these issues. First of all, I'd like to urge this audience to maybe cool the terminology that we use, the rhetoric of crisis, a little bit. I don't want to say that what we're dealing with here is not important. What we're dealing with here is of the greatest importance. But we need a little less panic and a little more thoughtful action. I sometimes say it's not a crisis after the 15th year of conversation. We have something here that is commonly referred to as a crisis, but actually what it is an ongoing social condition of great importance for us to continue to pay attention to. Uri Treisman, I thought, hit just the right note today when he said that we need to promulgate a message that's balanced between urgency and hope. That's absolutely right. If we keep going with the message of crisis and despair, sooner or later people are just going to say, well, maybe we're just never going to make any headway. We have to make people understand that there are things that can be done and that there's a reason to do them. There is hope. And what I'd also like to do is bring back the citation from Leon Letterman last night. And Leon actually said something I thought was very valuable when he commented that in many ways we have known for decades what to do, but we have a failure to execute. And I think that's right. And it, to me, points us to the fact that we don't really have ideal mechanisms for setting up an agenda and executing that agenda. In my experience in Texas and around the nation, there are probably too many voices and vehicles dealing with education reform issues, and we are not, from that cacophony of voices, creating a reasonable set of most important steps to take and just go do them. Continuous improvement has shown its merit in all kinds of theaters of action, in industrial processes, in corporate management, in governmental affairs. Continuous improvement works. And what I'd like to urge is that we try to concentrate a bit on bringing our voices together and finding some mechanism that can allow us to settle on a near-term agenda of a relatively small number of most important things, and then making sure that we actually follow through. Now, that, like all the other things that have been said here, are easier said than done. I think that I don't know who needs to bring that group together. Maybe in Texas it's the governor or someone in authority like that, but there needs to be a convening and a settling on a relatively small number of agenda items. Otherwise, we get into the Chicken Little mode. We're dashing around in such a large number, dealing with such a large number of agenda items that we actually never complete any of them. We also need, I think, through that mechanism, the ability to filter the more important from the less important, the more promising from the less promising, the scalable from the non-scalable. So that's one set of comments that I'd like to make. We need a mechanism for focus, and TAMIS may have some ability to try to help us get there. So I put that in front of you. By the way, I want to indicate that I see myself here as not building an agenda for you, but really trying to bring some overarching, gathering together ideas for you to digest what you've thought about today or heard about today, and an agenda needs to come from the people who are in better positions to act. Let me give you 5 areas of prime focus that I would emphasize walking away from this. Now, I'm not able to touch on every individual's talk, and I'm not going to make individual citations by and large. Here are the points that I would make. More good teachers has to be part of the agenda. Reaching higher needs to be part of the agenda. Emphasizing scalability needs to be part of the agenda. Attending to college readiness needs to be part of the agenda. And finding ways to fascinate needs to be part of the agenda. Those are the 5 rubrics that I'll give you. Now, let me make some comments from those. More good teachers, I think, is an area that we spent a lot of time talking about. I think there are many elements to this. The replication of the UTeach program is something that is underway under the rubric of the National Math and Science Initiative. I think it's a very good thing that that's going to happen. That is a proven effective mode of strengthening the availability of well-prepared math and science teachers. They don't all have to be at UT Austin. They can be at every university, but diversifying or broadening the base of people delivering and preparing teachers according to that model is a good thing, and that's something that I think should be on the small list of executable items. Induction is another thing that I would urge a high degree of attention to be placed on. We all know that if we can get teachers, good teachers, to stay in the classroom even a little while longer, it goes a long way toward fulfilling the need for talent, the need for teaching staff that we have in this country. Induction, in my experience and the experience of people I've observed, is something that's handled very poorly on the average in this country, phenomenally so in my mind. But we can, I think, gain a lot of ground there quickly. Let me talk more extensively about reaching higher. This is a rubric that I have to cover quite a bit that I'd like to talk about. We do need to reach higher in the schools, for higher levels of attainment by our students. We've heard today about the AP incentive program. I think that's a very good way to help faculty members in the schools and students in the schools to reach for a higher level of attainment in their own, in the case of students, in their own educational experience, and in the case of teachers, in their capability and in the level at which they are able to offer instruction. But generally, I think that we need to try to build a mechanism for recognition that's built off the accountability system or off of other things that takes into account achievement above the basic level. We have in our focus on accountability in recent years created too much focus on basic standards, basic minimum attainment, and not enough recognition for and not enough reward for, in the lives of schools and individual teachers, the ability to take students above the basic. Mike Martyr talked today about the fact that the commended category of attainment, even under tax, is not actually taken into account much in the Texas accountability system, yet he also showed how strongly correlated it is with college readiness. That's a major policy goal. College readiness. The accountability system and the way schools are recognized ought to take greater account of the higher level of attainment that is represented by the commended category. But I personally think that schools and school systems should be evaluated on other goals that are not now taken much into account. College going rates, college graduation rates, things that you really want to achieve in the lives of students that right now are not addressed. I think there needs to be reference to nationally normed tests. The Texas tax does do some useful things for us, but they're not nationally normed, and they don't tell us much about how well we're doing on let's say, a non-manipulable standard. Let me also point out that there was quite a bit of discussion here about the status of teachers within our society. If we manage to continue holding on to a system of evaluation that is aimed at fulfilling basic standards or minimal standards, which is what the tax does, we're not going to get an environment where teachers can be recognized as the sort of professionals that we would like to achieve. The public recognizes attainment and recognizes high achievement, and the public wants to see teachers doing the best things teachers do. They don't want to see teachers as guardians of the minimum standards. What I'm really trying to say here is that in order to get the public recognition that teachers deserve, especially the most accomplished of our teachers, we have to have a mechanism for presenting to the public the high level of accomplishment that they attain. And what I'm saying again is that being able to build into a recognition system and a reward system the component that has to do with high levels of achievement is integral to getting teachers the recognition that we all want to see teachers have. That is a little bit of a convoluted argument, but I think there's truth in it, that as long as teachers are represented to the public as simply the police of the minimal standards, we're not going to be able to get them the recognition that they need and ought to have. And finally, in this area of reaching higher, I'd like to put in a plug for recognizing students who walk through the door. In our society, we have put tremendous emphasis on opening the door. But we also need to recognize students who deliver, students who succeed, students who have actually achieved. We need that talent to go as far as it can go, to develop as high a level of achievement as it can, and we need to recognize those students who have done that. There has been a resistance in our society to doing that, and we need to get back to it. We're in a competitive environment worldwide. We have to be able to develop to the fullest degree the talent that we have, and we need to appreciate people who put the effort in to develop themselves. So that's what I mean by recognizing students who walk through the door. Emphasizing scalability is enormously important. The number of high school students, or number of students, public school students in this society is spectacularly large, tens of millions. We are not going to bring about public school or school improvement generally in this country if we can't attend to scalability. So I think as this mechanism comes into being, if it ever does, the one I suggested of having some way of digesting all these agendas of all these groups and creating a small list of most important executable things, scalability has to play a very strong role in the selection of items to go on that list, because we have to be able to replicate. We have to be able to generalize, to be able to take things to these millions of students for whom we're responsible. My fourth item was attending to college readiness. This is an idea or topic whose time is definitely before us. I think that the public and many public leaders are just coming to terms with the fact that graduation from high school does not imply college readiness. And that's been historically true, I think, in this society. It's only now, when we realize how important high school graduation is and the economic and social value of being able to attend college, that public and policymakers have gotten so interested in making that connection more real. But it doesn't exist at this point, and we are going to be in a serious debate in this state and elsewhere in the country about whether that's actually what we mean. And if that's what we mean, what does it imply for what we're going to do with students while they're in secondary school, and what does it imply for the condition of those students when they arrive in college? Though none of those questions has been worked through, but we're in the midst of doing it here in Texas right now, or at least we're in the midst of broaching the subject. We'll see how far we get down that road. But I would like to point out a couple of things about this issue, because I think it's a lot of important problems wrapped up in it, and I want to at least get you to start thinking about what your views are. One of the things I'd like to point out to you all is that despite dramatic changes in college-going rates in the United States, the fraction of our population that's actually achieved a bachelor's degree, actually graduated from college, has remained remarkably constant for about 50 years. It's around 25%. And it has, it's changed a few percent, and it's drifted up a little bit, but a college going rate has dramatically increased in that time. But the college graduation rate, the ultimate fraction of the population that actually achieves a bachelor's degree, has hardly changed. And it's very interesting that it's well matched in Texas to the college readiness rate. There has been in recent years quite a lot of work done, pretty sophisticated work done, some of it at the ACT, some of it at the College Board, about trying to define what college readiness means. And there are technical definitions. I won't get into what it means. But basically, it's about the idea of whether you can arrive at college, take college-level work without the need for remediation. About 18% of the Texas high school population, graduating high school population, is in that boat, is college ready. Not all that low, much lower than the fraction that we can predict is going to ultimately earn a college diploma. Michael pointed out today that there's also a good match between the percentage of students who achieve commended on the tax and that college readiness fraction. If we're going to achieve better alignment, if we're going to achieve genuine college readiness, we're going to have to find a way to get more people into that commended category and get them genuinely matched up to what's expected in college work. And finally, I'll just mention this last rubric that I gave you, find ways to fascinate. Alan Friedman talked about passion, awe, and wonder. Those are important in science and mathematics. I'm a chemist. I lived through the experience of becoming genuinely interested in science, and it happens earlier than a lot of people recognize. For me, probably in the elementary grades and amplified in the middle school. By the time I was 14, I already knew I was going to become a scientist. That's not an unusual story. But there have to be vehicles for getting kids enthusiastic about what's happening in the natural world and in the mathematical world. And most of it probably doesn't happen in school. Most of it probably is connected to that, Alan said 92% of life that's outside of school. Tamis maybe can find some ways to try to influence that. But there are historic examples of people who've made a big difference through television, through other media, through museums. But fascination is not something we can afford to neglect. And with that, let me say that we've heard a lot of words today, and it's now time for a drink.